Hello, I'm Jack, Data Science Principal at Aiimi. We're a tech company specializing in data, information, and AI. As Data Science Principal, I collaborate with cross-functional teams to help our customers rapidly solve big, complex data challenges. These solutions are subsequently assessed and confirmed by real business users. At Aiimi, the design stage of any project is invaluable, and that's why one of our key service offerings are design sprints. From our customized hack zone in Milton Keynes, we can set up clients to deliver ideation exercises, develop user-validated prototypes, and strategize how to redesign underperforming services or products. Close attention to a design stage of asset management will help better equip your teams for the build stage. For those of you who watched our previous webinar with the IAM, which is now available on demand to members, our Chief Customer Officer, Tom O'Farrell, explained why data-driven insights offer the best solutions to large-scale asset-centric challenges, why these insights are best guided by three fundamental principles. These principles being to treat data and content as equal partners. Number two, to automate information and governance wherever possible. And finally, to place UX at the heart of how you design information architecture. Today, drawing on my industry experience, I'm going to take you through each of these key principles in our next stage of the asset lifecycle, which is design. So first, I'm going to cover off data and information. So by treating data and information as two sides of the same coin, we can unlock a completely digital view of our assets, harnessing a combination of information assets, such as specifications, installation details, and maintenance plans, alongside our data assets, so running data, power consumption, weather. That enables us to build solid foundations for a digital twin. And actually, as a virtual real-time representation of a physical asset, system, or process, a digital twin is only as good as the combined data and information foundations, which it is built on. So a good example, which I like to go to here, is one of our customers, Anglian Water. So they have got a project called the Strategic Pipeline Alliance, which is to put in a huge game-changing pipeline on their network. Now, this asset is quite different from other Anglian Water assets in that it's being built specifically to integrate with a digital twin. And actually, the two projects, both real life and digital, are running concurrently. The systems are specifically designed to more accurately capture information on asset specifications than was the case in any earlier projects on legacy equipment. Plus, the pipeline data capture and telemetry have been explicitly planned to capture sufficient information to build that exact near real-time digital twin model. In both instances, both capturing information on design specifications and ongoing telemetry data, it's far easier to get the systems and processes needed for a digital twin the right first time, building them into the process, than it is to retrofit a digital twin to existing infrastructure. Although, of course, AI can indeed still benefit existing assets. So moving on to information governance. So on big projects, such as the Strategic Pipeline Anglian Water, it is crucial that extra efforts are made to ensure that all content is captured in a consistent manner according to good information governance practices. Now, by taking measures to ensure governance, such as harnessing automation, you can be 100% confident that you've adopted privacy by design, even when, for example, different contractors capture data in diverse formats, or you're dealing with legacy asset information, which must be then interfaced with these new assets and standards. At Aiimi, we don't believe that huge migration and translation projects actually deliver the right kind of value in the right kind of timeframes for any project. They can be hugely costly and out of date before they ever reach completion. Plus, it's just not necessary to put all information in one place in order to govern it. Instead, we believe it's better to use a data mesh to connect information across your diverse source systems and formats, bringing in old and new together. Now, insight engines are an emerging technology which enable this data mesh concept, bringing together data and information from disparate systems, transforming and presenting that content to each user as one unified collection, while still maintaining those source systems as the master data. For example, Aimi's own insight engine is actually being used by Anglian Water. Powered by machine learning, the Aiimi Insight Engine identifies document types and finds hidden information within those documents, such as asset codes, asset types, and sites. Front-end users can benefit from the ability to search for these technical details across several potential source systems and identify the information they need exactly when they need it. quick access to all existing asset data and information can obviously better inform and accelerate that asset design phase. So finding the right information with an insight engine actually relies very heavily upon an intuitive user experience. And in that same vein, at Aiimi, that's why we embrace a user-centric design sprint methodology as one of our key service offerings. We believe that this kind of methodology can solve just about any kind of problem. It was first developed by Google as a fast-paced process to design intuitive application interfaces, but I predict that design sprints are going to be gaining increasing traction across all industries and gain the ability to deliver innovative solutions to all types of challenges, obviously, including asset design. At Northumbrian Water, we've actually been using a design sprint methodology. So Northumbrian Water is aiming to better manage their operational fleet and develop a future-proof design based on an alternative fuel model. So something that they call the Mission Zero roadmap is to transform their existing conventional fleet into an alternative fuel fleet. And this challenge focuses on locations, timings, and costs involved, focusing on how best to improve the fuel efficiency of all vehicles, considering all options such as electric, biodiesel, and hydrogen-powered vehicles. To solve these challenges, we're using a design sprint approach to tap into that knowledge and experience held within Northumbrian Water across a cross-section of their business and the entire enterprise. This takes us one step beyond simply designing a user interface. Instead, we're taking a more integrated approach, including looking at business logic and the best data sources to enable their data scientists to build a full fleet optimization solution that actually meets those net zero targets. So, what we learned. The design stage of asset management is key to successfully building, operating, and maintaining your assets. This is because it affords the perfect opportunity to brainstorm ideas, opportunities, and solutions to those big asset-centric challenges facing your business. AI technologies such as insight engines bolster the design stage by connecting diverse and seemingly isolated data and information to reveal hidden value and deliver new insights. By automating information governance wherever possible, we can adopt privacy by design, and by placing the user at the center of your information architecture, you can drive a successful business-wide adoption. In our next session, we're going to continue looking at the value of accessing information across the whole asset management lifecycle, focusing specifically on how AI can help organizations maintain their existing assets.